Processing thermal paper for fingerprints has its own challenges because of the emulsion side of the thermal paper, that shiny top surface, which has multiple layers to it, that is heat activated during the printing process. It has an adverse negative effect when you process it or expose that thermal side of the emulsion side of the paper directly to the chemistry. So we've got a couple of options as to processing it. The first one we're going to do is using a sandwich method that was developed by Lawrence Passeron from the Toronto Police Service several years ago, where it's an indirect exposure to the chemistry. So you're going to pre-dip or pre-saturate blotter paper, or in our case we're going to use 2 pieces of filter paper with the chemistry, in this case the Indanedione zinc chloride, allow it to air dry, and then so the actual thermal paper is not being directly exposed to the chemistry, but indirectly by a sandwich method of the 2 pre-treated filter papers, one on the front and one on the back. And from that process, then the exhibit gets placed into a Ziploc baggie and then put into a dry oven at 60 degrees Celsius for about 15 minutes. And so that's what we're going to do. So just come closer as we do this little demonstration here. So I have already put fingerprints on these 2 pieces of thermal paper, and you can see that shiny aspect where the emulsion coatings are on. I put fingerprints on both the front and the back side. So I'll set those aside. Take 2 pieces of the filter paper. And we're using a working solution of the Indanedione zinc chloride, so I'll put some in the tray, sufficient quantity to saturate both of the blotter papers or the filter paper. So once it's completely saturated, we'll set that aside, that one, process the other one here, just saturate it. Same thing, once it's completely saturated, we'll set it aside to air dry. And you can see the first one's evaporating very quickly. It's important to make sure that they're completely dry before they come in direct contact with the thermal paper. Okay, so our first exhibit here, this thermal paper, we're going to use the ones that are already air dried here. So we'll put those together here and slip them into a small Ziploc baggie. So the idea behind this is that it will not have that negative reaction with the chemistry coming in direct contact with the thermal paper, which would result in a discoloration of the emulsion side of the paper. So this ideally will negate that or address that issue. Now, we'll put this into a dry oven at 60 degrees Celsius for 15 minutes, and we'll see what our results are. We may see some fingerprints with the Indanedione zinc chloride. Some fingerprints may be visible with just a pinkish color, and while others may still be more visible, they may be latent or more visualized by using an alternate light source. In this case, in the range of the 500 series, 500 nanometers range, in combination with an orange KV 550 barrier filter.
Okay.
Okay, so we've enclosed our 2 receipts and sandwiched them between the filter paper, and we're just going to go over to the dry oven, which has been preheated to 60 degrees, and we will put the samples inside there, and we'll let it sit for about 15 minutes. Okay. Okay, so our Indanedione zinc chloride thermal paper sandwich method is just about done now. It's been in for about 15 minutes. Just going to remove the items from the dry oven, and we'll go see what kind of results that we have. Okay, so let's open up our Ziploc baggies here and see what kind of results that we have. The pre-treated filter paper can actually be used multiple times. Just it may lose its potency after every occasion, so it might be good to recharge it again with some more of the chemistry. But we'll just set that aside for now. You can see here that we have some pale pink fingerprints that are already visible here. And you'll notice the purpose of processing it with the sandwich method is to maintain the integrity of the face on the emulsion side so that it doesn't discolor it. So now the prints are more easily visible and less confused or degraded because of discoloration from the chemistry on the surface. So by using that indirect method, it maintains the clarity of the detail on the impression. And on the reverse side, not as much, but certainly when we hit this with the alternate light source, it's going to improve the contrast and certainly the clarity of the prints on the ones that are already visible, as well as potentially the latent ones on the back.
The brightest and most intense fluorescence emission for the Indanedione fingerprint product occurs when the excitation wavelength is 505 nanometers. However, using alternate light sources slightly higher and lower than the maximum peak will still provide sufficient fluorescence, as you are providing energy on the shoulders of the peak of excitation. The lights are already turned off. I will start with the lowest wavelength, 450 nanometers. I see some fingerprints here. Next we have the 505 nanometers. And finally, here is how the fingerprints look like using 530 nanometers.